you. And good afternoon, everyone. And my name is Meng, and from SuperMap Research Institute, the 3D R&D Center. And today it is my great honor to have this opportunity to share you guys with the latest development of SuperMap 3D GIS technologies. Yeah, for over 40 years, GIS have helped users to manage, to analyze, and to map all kinds of data and improve better communication and efficiency, as well as better management and decision making. And among the years, 3D GIS also improves the evaluation and with realistic evaluation and advanced analysis, and will help to uncover the full potential of geospatial data over versatile industries. 3D GIS also drive deeper engagement and interactions with advanced 3D capabilities and seamless integrations with IT technologies. And it also allows users to explore and analyze spatial relationships in an intuitive way across a variety of devices, dashboard, and applications. And today, I will talk about the latest improvements about SuperMap 3D technologies in 5 aspects. Okay, the first one, let's take a look at the data model system. As our colleague mentioned before, after more than 10 years of development, we have gradually built a 2D and a 3D integrated spatial data model system for full space representations, including the object data model and describes spatial features like the 3D models, and the network data model describes the links and the relationships between the different objects, and the field data model describes the continuous and the distributed 3D phenomena such as the temperature distributions, and among them, the object model is one of the most important prerequisites for the building a computable and designable 3D-dimensional applications. And this is the exceptions of these object models, such as man-made models from 3D Max, and this is a BIM, building information models from maybe Revit or MicroStations. We use 3D network model to represent the 3D underground pipes to make, such as the, we use this topology to perform such as the stress analysis to find the shortest parts in different pad points. And we can all use the field model to overlay the professional 5D analysis results on the 3D buildings to optimize, to help our constructors to optimize the 5G networks. 3D GIS technology also supports the creation of digital twins for social or natural and built environments by offering a variety of geo-designing and modeling tools. And we also provide users with 2 3D modeling capabilities. The first one is the parametric modeling. It is very effective. We use 2D and 3D point, line, and polygons, and use this attribute information to fast build models. And the second one, combined with the interactive modeling technology, more flexible modeling, editing, and modeling can be achieved. Here is an example to use the parametric modeling. We built a tube while model use the attribute information, use the maybe the vector, like such as the points and the lines, and along with the information and the model symbols to build a whole underground pipeline systems, and built on and based on the attribute and 3D models, various well chambers and covers can be customized. We also could build a urban underground pipeline in a very short time. And another example, we can to modeling the roads with the original design scheme and the road set line. And the 3D road models can be very flexible and fast generated. And here is an example about the building draft modeling. We use the 2D architectural design plan coupled with the corresponding planning rules to build the whole campus with the buildings and the parking lots, and could be generated automatically. And in order to achieve more efficient 3D modeling, we also provide users with a variety of geometries and the model operators to provide users with more practical modeling capabilities. The second part is the spatial data access and the virtualizations. And 3D now could help users to gain greater insights and understandings with multi-source geospatial data access and high-realistic virtualizations. Over the past 10 years, we have access to various types of 3D data. At present, our data management capabilities have covered many different data types, such as the terrains, images, 3D mesh, point clouds, and the increased data storage have put forward higher requirements for the efficient management of all kinds of data. Let's check out this video. Yeah. Okay, click the screen. Okay, thank you. And this SuperMap 3D could stream a high accuracy and with full scale globe and allow instant access to cloud-based global high-resolution photogrammetries, terrains, imageries, and buildings, and virtualize many massive real-world 3D geospatial contents as runtime. As for the beam combined beam with the GIS, because as we all know, repeated data conversions could cause inevitable geometry or the attributes information losses. So maybe in 2015, we provide different direct integration between the beam modeling software and the GIS platforms. This comes down to have the ability to direct access and or import more beam data into GIS programs and keep this original file structure and information, such as the original materials. Let's check out this video. With direct access to the beam data, we could use the original materials, such like the metalness or the roughness of the metal and the ceramics, to provide the more beautiful and vivid scene for the users. And for the railway construction, we could use the real world physically based rendering techniques to represent the original structures of the data. As for the cities, this is the day view in Beijing. We also have many rendering techniques to make the buildings, to the water, and to the trees to perform a better visualization effects. And here's the net view. We also have the other maybe high-realistic techniques to provide the night views. Using the light and the shadowing, we can also give the users a better expression of what happened under the real night views in Chengdu. The next one is the day and night views. This is in Shanghai. This is all the techniques as we use is in the real time to render over maybe 700 kilometers in the models with the animations on the buildings. And we also provide many special 3D special effects to make a more 3D scene more realistic. And as for the performance, we improved better data optimization techniques and more precise rendering strategies to tap the potential of today's ever-growing collection of 3D geospatial data. And by doing this, the GPU usage will be lower by 30%, and the performance will be enhanced by 40%. And this is a video to structure. I'm sorry. And this is the video we can click. Okay. To stream the 3D mesh, the overall file size is over 3.2 terabytes, and with the land coverage is more than 400 kilometers. And this is the beam buildings designed by the beam and with more than 1 million objects inside the buildings. We can stream this at runtime in the WebGL, use it as a browser. And let's check out this video. This is over 1,010, 1,000 kilometers, and 3 multi-source data, including the beams, the 3D models, and the terrains and the imageries, and the 3D mesh. And we could create a realistic 3D digital representation to simplify complex issues and explain the whole scene to the stakeholders to make the better decision makings. The third part is about the spatial analysis. Advanced 3D analysis could maximize the potential of the geospatial data, and with the SuperMap GIS, you can analyze complex geometries and resulting in faster and smarter data-driven decisions. 3D spatial analysis now offers enhanced performance with the use of GPU, and this technology takes advantages of the parallel computing power of the graphics to improve the performance, which can be used for the sightlines or for the skyline analysis. And what has to be mentioned is GPU analysis has no real analysis results returned because of its technique features, and it will be limited in use. And through the improvement of our technologies, we achieved to get the analytical results that further improve the ability of 3D spatial analysis and make the analysis results more accurate and the applications more flexible. And this is the cut and fill analysis. We can get the calculates about the volume is about 3,000. This is the profile analysis, and we drew a line, 3D line, and we know the buildings profiles along the lines. And this is a sightline analysis from a viewpoint to the target we can see whether the line is obstructed or could be see-through. And this is another planning tool called skyline analysis. You can draw a line across the skies. Another useful query is we call it the spatial query. We drew a polygon to see which is the buildings is inside this area and which is outside. This is the sectioning, especially used in the beam data. We can adjust this length or the height to see the interior design inside the buildings. And this is another analysis tools, the view shed and height measurements. And the simulations about the weather. Okay. The third part is about the spatial data fusions. Spatial data fusion, I think, is the merger of different spatial data assets to create a unified data set or uniformly accessible database to provide a better understanding of situations. And now we could, to do more things than virtualization, we could use many operators. We have the geometry algorithms to deal with the data with different accuracy can be fused by the certain operations and tool sets, so that, as we see in this picture, the beam and the oblique photogrammetry can be seamlessly integrated with each other. For example, we can do some operations on the layer. So maybe we could flatten the oblique imageries and put the beam data on it and do some sections to see the accessories inside. This is an application to operate the terrains to make them calculations to match the beam models. By the operation, we can modify the terrain to fit the model data to ensure better modification with results. Here is we could overlay the 3D models on oblique images using the mosaic operators to make different data match each other with better visualizations. And this is a real case happened in the road construction. We could use the vectors, the lines, to calculate it with the oblique photogrammetries to build the road. And for the custom workflows, because every partners or the users have their own data and their own business scenarios, we could provide a lot of operators to form their own workflows, from data access to data processing to the data published, to form a whole workflow and to reduce the labors. In addition, we provide maybe more than 100 geoprocessing operators, including the data import processings, and to modify or the generation some of the tiles to achieve from the data accessing to the multi-ends applications to help our users to form their own workflows. And here's another video which shows this. And based on the tailored workflows, we help our partners to realize the integrated application of a BIM model and the GIS context for better linear engineering. Also, the last part is about the user case. And the first one, yeah. In military, we could, our partner used 3D to create more powerful special applications, bring the real-world details and accuracy to simulate military and trainings. And in the, sorry. Okay. In the municipal management, we could easily access to the public information with online zoning, utility, and the parcel maps and other public data, and we could track or plan for this infrastructure maintenance and updates related to the, something like water, pipeline, electricities, and roadways. And we could virtualize and explore and assess the opportunities and the challenges associated with the future growth and the developments. And this is about the city plannings. We could use leverage the BIM data with the oblique imagery models to form more detailed design plans. And the geological conditions could also be taken into considerations for the design safety assessment. And combined with the IoT data to represent the noise influence and to make a better understanding about the surroundings and determine the most suitable locations for the new homes, business, schools, and parks. And this is about the IOC, means Intelligent Operating Centers for Smart Cities. And we could to combine all available data and give stakeholders a real-time insight into the operation of the city. And in the IOC could analyze different real-time data sources to tell what is happening at any given location and any given time. And this is about the building plans in the real 3D context. We could draw the polygons and cite the parameters to make the 2D vector into 3D buildings. And this system enables planners and design professionals to collaborate across teams with a web-based 3D applications. We also use many analysis tools to provide better, more information and for better decision makings. The sunlight analysis, such as. This is one is about the traffic or the highway construction, the Yanjiang Expressway, and it is a winner in 2021 of the Building Smart International Design Award. Okay, let's make a summary. And the latest 3D GIS technology lets in more flexible modeling and more powerful data management and better performance and better visualizations on various devices. And we hope that our products technology can help users to implement more virtualized and computable, analyzable 3D GIS technologies. That's all for today. Thank you.